Google has recently introduced several groundbreaking AI advancements, with one of the most notable being Mixture of Depths, MOD. This innovation tackles a major inefficiency in transformer-based language models, where every token in a sequence receives the same amount of computational power. Researchers at Google DeepMind have demonstrated that computational effort can be allocated dynamically. Certain tokens undergo the intensive self-attention and MLP computations, while others bypass these processes using a residual connection. The core idea behind Mixture of Depths is straightforward. Instead of treating all words in a sentence as equally significant, MOD identifies which words require more processing and which do not. It then directs more computational resources toward the important ones while skipping over the less critical ones, resulting in a faster and more efficient model. Essentially, it functions like a reader who focuses on key points in a book while skimming less relevant content, without losing any essential information. The approach utilizes a per-token router, which assigns a scalar weight to each token in the sequence. The top K tokens, determined by these weights, undergo the standard self-attention and MLP processing in that transformer block, while the remaining tokens take a more computationally efficient path that skips the block. This significantly reduces flops, since not all tokens require equal processing. One of the key advantages of this method is that it maintains a static computation graph, as the capacity is predefined for a specific K value. This ensures efficient hardware utilization. The tokens selected for full computation can vary across sequences based on their complexity and importance. In their research, MOD's developers set this capacity well below 100% of the tokens. For instance, they configured it at 12.5%, meaning only 256 out of 2,048 tokens receive full processing. Moreover, they found that applying this selective computation only in alternating transformer layers further reduces the total compute cost while preserving or even enhancing performance. The surprising outcome is that MOD not only matches but often surpasses traditional transformers in language modeling performance while requiring significantly fewer flops per forward pass. This efficiency allows for either larger models within the same budget or longer training durations without exceeding computational constraints. The selection of top K tokens is determined by the router's output, and researchers discovered additional benefits, such as a reduced memory footprint and up to a 50% speed increase during post-training sampling. A key challenge they faced was ensuring efficient autoregressive sampling, since top K routing typically requires full sequence router outputs. To overcome this, they introduced a small auxiliary predictor that approximates top K decisions in a causal manner. This enables each token to determine its computational path without requiring a look-ahead into the full sequence. The performance impact is minimal, estimated at around 0.2 to 0.3%. Researchers also integrated the Mixture of Depths with the Mixture of Experts, forming what they call mode. This method allows entire blocks to be skipped for some tokens while routing them among different MLPE experts. Their findings show that this combination results in improvements beyond merely reducing capacity in a standard MOE. They conducted isoflop comparisons at scales of 6 × 10 to the 18th, 2 × 10 to the 19th, and 1 × 10 to the 20th flops. Their results indicate that the MOD approach achieves the same or even better training objectives than baselines, but at a significantly lower forward pass cost. In certain configurations, the model outperformed the baseline by up to 1.5% in the final log probability objective. Furthermore, they observed that when capacity is significantly reduced, such as when only 12.5% of the tokens are processed, efficiency gains still occur, provided full capacity layers are interleaved. The researchers noted that some tokens require less processing, and skipping computations for them frees up capacity for tokens that need it more. Meanwhile, Google has announced that its VO2 AI video generation model will cost 50 cents per second of generated footage, equating to $30 per minute or approximately $1,800 per hour. This service is positioned as a premium tool designed for professionals and businesses needing high-quality yet concise video content. John Barron, a researcher at Google DeepMind, compared this pricing with the cost of producing a Hollywood blockbuster like Avengers: Endgame, which reportedly cost around $32,000 per second. In contrast, Veo 2's pricing appears relatively affordable for major studios. However, users may still pay for generated footage they ultimately do not use, as Veo 2 can produce clips of up to 2 minutes in length. Another development in text-to-video AI is that Freepik has begun offering early public access to Veo 2 within its Creative Suite. The first 10,000 users can try 2 free generations, after which the cost is determined by credits. Each 5-second video requires 1,000 credits, and Freepik's cheaper Essential subscription costs $69 per year, providing 84,000 credits, enough for up to 84 short clips. This pricing structure may be expensive for users who need extensive AI-generated footage, but it is likely tailored for short commercial-style videos used in presentations and marketing. Additionally, Google has introduced the AI Co-Scientist system, which is designed to assist researchers in forming hypotheses, suggesting experiments, refining ideas, and generating in-depth research overviews. Google's new AI system, built on Gemini 2.0, operates using a multi-agent architecture. It includes several specialized agents: the generation agent, reflection agent, ranking agent, proximity agent, evolution agent, meta-review agent, and a supervisor agent that oversees everything. Each agent has a specific role. One generates initial hypotheses, another critiques them, another ranks them through a tournament-style process, and so on. The ranking system is based on ELO ratings, similar to those used in chess. When a lower-rated hypothesis outperforms a higher-rated one, it gains more ELO points, allowing the system to improve over time. The team behind this AI introduced novelty and impact metrics to evaluate its performance compared to other AI models. The Co-Scientist variant scored a novelty rating of 3.64 and an impact rating of 3.09, surpassing the Gemini 2.0 Pro experimental setting, which had a novelty of 3.27 and an impact of 3.00. OpenAI 1, in comparison, scored 3.09 in both novelty and impact. The Co-Scientist version proved to be the best, achieving a lower average ranking of 2.36, making it the preferred choice in direct comparisons. One of its most remarkable achievements was solving a decade-long mystery about antibiotic-resistant bacteria in just 2 days. Professor José Pinadas and his team at Imperial College London had spent 10 years investigating how superbugs develop resistance. They discovered that certain bacteria acquire viral tails, enabling them to transfer between hosts. When Google's AI Co-Scientist was given the same challenge, it independently arrived at the same conclusion in just 48 hours, despite the fact that this theory had never been published. Additionally, it proposed 4 other plausible hypotheses, proving it wasn't simply memorizing existing research. Initially, Pinadas suspected that the AI might have accessed his private files since the correct theory had not been made public. However, Google assured him that this was not the case. The results convinced Pinadas that this AI approach could revolutionize research by eliminating dead-end experiments faster and guiding scientists toward more promising theories. Meanwhile, there are reports that Google is testing AI-powered video creation features within Gemini. Code references in the Google app suggest a project called Robin, which appears to be related to advanced text-to-video generation. Observers found snippets of code mentioning progress messages like "working" and direct references to video generation. Google has not officially announced how or when this feature will be available to users. However, speculation suggests that a future Gemini version might allow users to type a prompt and receive a short AI-generated video. The current text-to-image system in Gemini is powered by Imagen 3, but it is possible that video generation could become more accessible through a consumer-friendly model like V02. One major factor to consider is cost, as these models require significant computational resources. Free or low-cost versions may offer limited, shorter videos, while a paid tier might unlock the full capabilities of the system. Access could integrate with other Google services, such as the business-focused Google Vids or Google Workspace tools like Google Vids for presentations and marketing. This entire approach aligns with Google's broader goal of consolidating various AI functionalities under one platform. In the future, Gemini might evolve into a unified interface capable of handling text, images, and video seamlessly. That wraps up everything on Google's latest AI advancements. What are your thoughts on mixture of depths, VO2's pricing, or AI co-scientists solving a decade-old mystery in just 2 days? Share your opinions in the comments. Don't forget to like and subscribe, and I'll catch you in the next one.